All right, guys, how's it going? Welcome back here in the classroom again. Thank goodness. I love working from home. Don't get me wrong; it's nice, but it's kind of nice to be back in the room here. I've got my camera back, got my calculators back, and so we're ready to do a video tutorial for those of you using this TI-nSpire. We're going to show you how to do a few things with the normal distribution on there. And do that little trick or that graph for assessing normality. So grab your TI-nSpire. If you have a TI-89 or a TI-84, what are you doing watching this video? You got your own video. Go back, go check out the other videos. This is not for you. All right, guys. I have a data set that I've already put into the calculator here. I will let you know when the time is right, what page that data set is on. And that way, if you want to, follow along with your calculator, you can input the data set so that you can see if you get the same kind of graph that I do. What I want to do first, though, is just show you like basic normal distribution calculations, and then we'll go into doing the stuff on the video. So I'm sorry, the stuff on the graph. I'm going to switch over to my document camera here. Yeah, it takes a second, but I'll edit this bit out, so it's all right. And here I am on my document camera, and I had it zoomed in earlier today, so I'm a little bit close. Sorry. Let me back that out a little bit. And you can see that I'm just sitting here on the main screen for right now. And what I want to do first is kind of show you the basic of the normal distribution computation before we go in and take a look at how we make the normal probability plot. So I'm just going to go to a regular old calculator screen, okay, which is this button right here, okay, that icon there. And here we are. And I'm going to push the menu button, and I'm going to go down to number 6, which is statistics. And if you look in your list here, look at choice number 5. It's our distributions menu. So I'm going to go to that. And you see a whole bunch of distributions listed here, okay? We're going to get to them. We're going to get through most of them this year. But the one we're going to use, probably more than any others, is the second one down, the normal CDF, okay? That is the normal cumulative density function, okay? And what this does is it's kind of like using table A, but kind of not like using table A, because we don't have to have the mean be 0 and the standard deviation be 1. It defaults to that when you first start it. Mu is 0 and standard deviation is 1. But I can use any distribution, and it will automatically convert to z-score, go to table A, look it all up, and do it all automatically for me. Now, your calculator, because you bought the modern calculator, understands infinity. So you notice right now my lower bound is set for negative infinity. This is just like what table A does. It tells you, like, we're going to find a score and find the percent of scores below it. Okay, so as you remember earlier, I mentioned the heights of American women are approximately normally distributed with a mean of 64 inches and a standard deviation of 2 inches. So perhaps I'm interested in, well, okay, so what would the percentile rank for a woman who is 60 inches tall be in the US? Okay, in other words, what percent of women are shorter than her? Okay, so I'm going to leave my lower bound at negative infinity. My upper bound is 60. Okay, so it's from 60 and below, and the mean is 64 and the standard deviation is 2. And I hit enter, and there we go. It tells me that, oh, that woman is taller than about 2.28% of all US women. There you go, easy peasy. If you want to do the proportion of women who are maybe 66 inches or taller, okay? So now my lower bound is 66 inches, and my upper bound is going to be infinity. Now, to get to the infinity, there's a pi button way down here at the bottom. See this little pi button, this little guy down here? That's the button I'm going to hit. And it brings up this little menu. And you can see this choice over here. There's the infinity symbol. Okay. And again, mean is 64. Sigma is 2. And if you are 66 inches tall, you are shorter than 15.9% of women in the US. So the 66-inch tall woman is taller than quite a bit, but she's still shorter than about 16% of women. So taller than 84% of the women, but shorter than 16% of women. Okay. Finally, if you wanted to do in between those two, you could. Okay, statistics, go to distributions, number 5, go to normal CDF, the second one down, and say, well, what percent of women are between those two? There's a 5-foot tall woman. There's a 5'6" woman. And you would get, oh, that is 81.86%. So there you go. That's the normal CDF calculation. I know I went through that pretty fast, but hey, this is a video. Push pause, rewind, do whatever you got to do. You can figure out how to do those computations. The key is to make sure you're using the normal CDF, the cumulative density function, not anything else for right now. Okay, let's talk about assessing normality. I have a data set entered in my calculator. It's over here. Okay, this is from page 125. So if you want to follow along with me, you can. This is the rates of unemployment for all 50 states, but it's from 2009 because our book is drastically out of date. All right, and I'm going to call this list unemployment. I'm just going to call it unimp. There we go. Okay, this is all 50 of the states in 2009. Of course, the rates would be quite a bit different right now. Thank you, COVID. All right, if you need to right now, push pause, enter the data into your calculator, then pick up here because we're going to go on. I'm going to make a graph using this icon here. And like usual, it comes up as a mess till I move the cursor down here to the bottom. Click and add my unemployment variable. And it makes a dot plot. And so right away, if I'm assessing normality, I look at that and go, gosh, does that look like it's approximately normally distributed? Doesn't look terrible. Doesn't look great though. Maybe a histogram would be better. So I'm going to change my plot type to histogram. Okay. And then, yeah, now I start to see maybe some skewness. Again, I don't like the histogram creation in the TI-nSpire because it always uses too many bars. So I'm actually going to go in and fix that. I'm going to say, well, let me go in here to histogram bin settings, go to equal bin width right there. Oh, there's the problem. The width was set for 1. Okay. And, you know, I had from 14.7 down to 4. So, you know, if I wanted to have 5 categories, that would give me a bin width of about 3. Let's try that. Oh, now I only have 4 bars. But, oh, wait, I got to remember to zoom, right? Zoom to fit my data. Yeah, I'm not happy with that number of bars. So let me try one more. I think I went too far in the width there. I'll try to. Ah, there we go. And that's not bad. It kind of looks normal-ish. But it's hard to tell. I could do the 68, 95, 99.7 rule stuff. But the reason I brought you here is I want to show you how to make the normal probability plot. Remember, normal probability plot, the unemployment data will still be the x-axis, but the y-axis over here is going to change to be the z-score for each one of these data points. When you go to plot type, you probably saw it when we were there earlier. It's choice number 4. And then we say, well, do we have a nice linear look to our normal probability plot? And yeah, we kind of do, but I got a real problem with this little bit right here because it starts to curve down here. And I got an issue with this normal, with this being normal, with this dot way out here. That's starting to look an awful lot like an outlier. And normally distributed data doesn't have a lot of outliers in it. And so to have a set where I randomly picked up an outlier doesn't seem likely. So at the end of the day, I'm going to say, I wouldn't feel real comfortable modeling this data with a normal distribution. So That's how we make the normal probability plot. All right, guys. That's it. That's really all I wanted to do was just give you some practice or some tools in terms of finding normal distribution probabilities or percentages with your calculator. And also I want to touch on how we could figure out the normal distribution.